The RADx Data Hub is a file-based data repository. Each RADx study produces data that is stored in files, and these files are then uploaded to the Data Hub by the RADx Data Coordination Centers, or DCCs. As you'll see in the demo that's coming, when you browse the Data Hub, you will see all of the data files that have been uploaded to the hub and associated with a given study. It's possible to search for files using their associated metadata. Within a study, files are actually grouped into bundles. As you see here, we have a bundle that contains different kinds of files. And each bundle contains data files and metadata files, where these metadata files serve the purpose of describing the data files. Bundles may also contain README files and other study documentation files, such as protocol descriptions. At the bottom of this slide, you can see an example file name, survey1_data_transform_copy.csv. Each file is named in a very specific way that consists of a prefix and a suffix. The prefix indicates the bundle that the file belongs to, so that every file in the same bundle has the same prefix. The suffix indicates the type of contents, the purpose of the file, and how the data in the data file has been processed. In this example, we see a suffix of data_transform_copy. This suffix, or this particular suffix, indicates that the file contains data, and that moreover this data has been processed to harmonize it. There are several different suffixes, and I'm not going to go into a great detail about these here, as the RADx Data Hub documentation contains more information. All bundles contain one data file that is formatted as a comma-separated values file. Each row in this data file represents a data record, and each column in a row represents a value of a data element or a variable. Data files come in two types, non-harmonized and harmonized, denoted by the suffixes origin copy and transform copy. Every file in a RADx bundle contains a non-harmonized data file. And this file contains data that has been produced by a RADx investigator and has been minimally processed by one of our RADx data coordination centers to ensure well-formedness. Non-harmonized files are denoted by the suffix origin copy. Now, if a bundle has data files that contain human study data, then there's going to be a second file with a file name suffix of transform copy. And the data in this transform copy is derived from the data in the origin copy, that's the non-harmonized file, by a process known as harmonization. During the harmonization process, data is relabeled and recoded in a uniform way, so that no matter what format and encoding was used for the original study data, the data that's presented in the transform copy file is uniform across all different studies. Each data file is accompanied by two other files, a meta file and a dict file. So each file is identified through the meta and dict suffix segments, as you can see here. The meta file contains structured metadata about the data file. So things like who, where, how, and when the data file was created. The dict file is a data dictionary file that provides precise descriptions about the columns in a data file. Things like the name, the data type, permissible values for the columns, for example. The most relevant metadata for people working with a data file is likely to be an accompanying data dictionary. So let's go into a little bit more detail here. As I've said before, the data dictionary explains the meaning of columns in a data file. So let's take a look at some data. You can see this in the middle of the screen here. And this is a portion of a data file from the RADx synthetic data set. I'm going to focus on the second column from the left, the one that's highlighted. And this column is headed positive year underscore COVID test underscore 1. So you can see from this heading and these numbers that in itself, there's not really any meaningful information. And indeed, there's not meaningful information without the accompanying explanation provided by a data dictionary. So here we just have a set of integers, and we don't know how to interpret the values 3 or 2 or 99. But the data dictionary in the dix file specifies what these actually mean. And in the bottom of the screen here, on the second row, you can see the description of positive year underscore COVID test 1. And you can see that there's a label that gives a human readable name for this. But moreover, you can also see that 3 is a code for the year 2021, and 2 is a code for the year 2020. The data dictionary provides other information, so not everything is shown here. And this other information explains the semantics of columns in a precise way so that it's possible to correctly interpret the data files for reuse.